Hello, my name is Hira, and today I am excited to walk you through my project titled Trust Management for Composing Distributed Software System in a Global Marketplace. This project was part of my MSc degree at Leeds Bucket University. Over the next 10 minutes, I will take you through the journey of this project from the initial concept to the final outcome. Following table of content, I will discuss you step by step. Trust management is vital for enhancing the security, reliability, and performance of distributed software system into the global marketplace. This study focuses on three trust management algorithms: AHP, WSM, and VCore, applied the WS Dream dataset. These models are examined to assess their suitability for distributed environment. Aim and objective. To investigate and compare different trust management algorithms for distributed software system in global market. Objectives: analyze current trust management algorithm and their relevance to distributed system. Evaluate the effectiveness of trust management algorithm in improving reliability, security, and performance. Compare performance and scalability in a global transaction environment. Motivation: as distributed systems grow in complexity, managing trust become critical. Traditional trust models like Bayes' inference are no longer adequate for modern systems. Algorithms like AHP, WSM, and VCore offer more structured approaches addressing the growing needs to robust trust management mechanisms. Research gap: while traditional models have been used extensively, they often fail to scale in today's complex environment. This research explores newer scalable models AHP, WSM, and VCore that have not been fully utilized in the context of distributed system. Literature review: traditional models like Bayes' inference, dumpster Sheffer theory, and fuzzy logic have been widely studied, but new trust management architecture such as centralized, decentralized, and hybrid models provide alternatives. Recent studies have shown the effectiveness of AHP, WSM, and VCore is handling multi-criteria decision making in distributed environment. Methodology: this research used both qualitative and quantitative approaches with the WS Dream dataset used for analysis. This dataset is pre-processed and exploratory data analysis is performed to understand geographical, distributed, and QoS metrics like response time and through output. Trust models like AHP, WSM, and VCore are applied to evaluate trust score based on criteria such as reliability, security, scalability, and performance. Implementation: the WS Dream dataset was loaded and preprocessed to handle missing value and normalize QoS attributes. Exploratory data analysis was conducted to visualize data trends. The AHP, WSM, and VCore algorithm were implemented using Python to calculate and compare trust score for various web services. Hi, this is the implementation of my product. First, I import my data set from Google Drive, and then we import the some necessary libraries such as Panda, Num, and Metapult, Seaborn Time. After importing the libraries, we loading the dataset and this is the web services list of dataset. and here is their ID and WSDL address, services provider, IP address is country, IP number, and latitude and longitude. And this is the list of web services data set. Then we loading the user list of data set, and this is the user IDs, IP address, country, and IP number, and as latitude and longitude of the user list data set. And this is the user information list. Then we loading the QoS data response time, and this is the RT matrix of QoS data set, and also the throughput, and this is the RT matrix list of throughput QoS data. And then I do the data pre-processing, missing value in a user services list, and this we check the missing value in a user list and the missing value in a web servers list, and there is not zero is a missing value. And then I do the importation of missing value, and we in the IP address, and as I mentioned in a unknown for the missing value. Use the unknown importation, and the missing value is here, and there is a no missing value, all is 0. Checking for missing value in RT matrix and TP matrix. Then we check the missing value in RT matrix. There is a missing value in RT matrix, and there is a missing value in TP matrix. Then we drop the column, then I drop a column with none value in both RT matrix and TP matrix. And checking duplicate row in dataset. First I check the duplicate. There are two lists of a duplicate rows in dataset, and removing then I remove the duplicates list of dataset. Checking the shape of dataset, then I check the shape of dataset and print out and then print the shape of QoS dataset. And then then I implement the exploratory data analysis. There is a top 20 countries by number of web services, and there is a graph of top 20 web services, and there is a top 20 countries by number of user graph. There is a graph of number of user in top 20 countries, and there is a graph of latitude distribution and longitude distribution. Latitude and longitude distribution of user. There is a graph that is a latitude distribution of user, and there is a longitude distribution of user. And then I do throughput and response time heat map. I got this, and there is a throughput heat map, and there is a response time heat map of subset of services. Where is the darker color, there is a more user of services. Distribution of response time and throughput of all services. There is a graph that is a distribution of response time of all services. There is 0 to 5, and there is a distribution of throughput of for all services. Mean response time and throughput across all services, and there is a graph of mean response time across services and mean throughput across services. And then I do the correlation of analysis matrix, and there is a graph of correlation matrix of normalized criteria. There's reliability, security, scalability, performance, and services IDs. Trust management algorithm of AHP, WSM, and VCOR. Bar chart of top 10 services by trust score is here. There is AHP trust score, WSM trust score, and VCOR trust score. And this is the result and comparison of AHP trust score, WSM, and VCOR trust score. There are top 10 services of trust score AHP, WSM, and VCOR. Result in comparison, the results show that AHP provided balanced trust score. WSM was faster and more suitable for real-time system, and VCOR excelled in handling conflicting criteria. Visualization through bar chart display on the top 10 web services ranked by AHP, WSM, and VCOR Trust Score, highlighting each module unique advantage. And this is a comparison of performance and scalability across the algorithm. The uh, average value of AHP is AHP performance is 0 point something 3 and 4, and the scalability is 0.9 or something. Otherwise, the second WSM algorithm performance is 0.5 and 0.4 and mid of 0.6, and the scalability of WSM algorithm is 0.7 something. Also, the VCOR performance is average value is 0.5 or 0.4 something, and the scalability of VCOR is 0.76 or something. Since the performance evaluation of real-time computational efficiency across algorithm, the computational time is AHP is 0.0044, and the WSM algorithm is 0.008, and VCOR is 0.0101. The best is WSM because they take a very short time. The result in comparison, when comparing the algorithm, AHP showed balanced performance. WSM was computationally efficient, and VCOR was better at resolving conflicts but took longer to compute. The computational time, scalability, and performance of each model were visualized, showing how each fits different use cases. Conclusion and feature research. In conclusion, AHP is ideal for balanced evaluations, WSM is best for real-time application, and VCOR is provide detailed trust analysis in scenarios with conflicting objective. Future work could explore additional trust criteria, different data sets, and integrating these module with blockchain technology for enhanced security and transparency. Hello, my name is Hera, and today I am excited to walk you through my project titled Trust Management for Composing Distributed Software System in a Global Marketplace. This project was part of my MSc degree at Leeds Bucket University. Over the next 10 minutes, I will take you through the journey of this project from the initial concept to the final outcome. Following table of content, I will discuss you step by step. Trust management is vital for enhancing the security, reliability, and performance of distributed software system into the global marketplace. This study focuses on three trust management algorithms: AHP, WSM, and VCOR, applied the WS Dream dataset. These models are exempt to these models are exempt to assess. These models are exempt to assess their suitability for distributed environment. Thank you for taking the time to review my project demo. Your attention and interest mean a lot to me. I hope the presentation was clear and easy to follow. I appreciate your time and feedback or question you may have. Thank you so much.